Hello, this is Professor Keen. We've been talking about Aristotle's On the Heavens. Now we're on Book 2, Chapter 14. This is in my A Student's Guide to the Great Physics Texts, Chapter 4. The question that Aristotle is dealing with in this Chapter 14 is, does the Earth move or not? Some people argued that it is one of the stars or one of the planets. Remember, this is what the Pythagoreans believed, that the Earth is one of the planets that's going around a central fire. By the way, going around a central fire, that sounds a little bit strange. I think it is a little bit strange. Some people have argued that the Pythagoreans really mean the sun that the Earth is going around. That's what Kepler thought, by the way. Others argue that the sun and the Earth are both going around some central fire. It's not entirely clear to me. In any case, the Pythagoreans did believe that the Earth was a planet moving around through space. Other thinkers, like Plato, believe that the Earth was at the center of the universe, the center of the world, but it's spinning around its own axis, and that gives rise to the apparent rising and setting of the stars every day. Aristotle, of course, believed that both of these ideas are false. He said that if the Earth's motion is constrained, that is, it's constrained to move in a circle, then you would expect any part of the Earth to exhibit this same kind of circular constrained motion. But we know that pieces of Earth, like rocks, when you drop them, they fall straight down. So the Earth's motion must not be constrained to move in a circle. Also, as Aristotle mentions, the universe is eternal. That is, as far as people have been watching it, it's been doing the same thing, and constrained kinds of motion cannot be eternal. They tend to pass away, to die away over time. Furthermore, another reason that he believes that the Earth is sitting still and not moving around in a circle is that the planets, let's take the Pythagoreans seriously for the moment. Let's suppose the Earth is one of the planets. Well, we know that the planets exhibit not a simple motion, but rather this progression and retrogression through the zodiac. We talked about this a couple of lectures back. Only the primary sphere, that is the sphere on which the stars are located, is executing a very simple single circular motion. So if the Earth was one of these planets, if it was to be classed as one of these planets, then it should have more complex circular motion, which would really manifest itself as a more complicated motion of the stars from our perspective. If the Earth was doing this funny motion, kind of progressing and retrogressing, the stars from our perspective, looking at them from the Earth, should be exhibiting this progression and retrogression, which is not observed. Aristotle argues, therefore, the Earth is not one of the planets. Okay, so we've been talking about Chapter 14. Let's continue in Chapter 14 here. One of the things that Aristotle brings up here is that the Earth, being at the center of the world, that has implications for how we see dropped objects. Do dropped objects, in particular, think about a rock, do they fall to the center of the Earth, or do they fall to the center of the world? This is a little bit confusing because the center of the Earth, after all, is coincident with the center of the world. So he argues that rocks, when you drop them, are trying to achieve the center of the world. And so let me draw a picture here. So if you imagine the universe like this is the universe, and the center of the universe is right here. And if the Earth was off-center, let's suppose the Earth was over here, and you're standing on the Earth, I know this isn't to scale or anything, but you get the idea. If you're standing here on the Earth, and you dropped a rock from here, and let's suppose that it's going toward the center of the world. It's aiming for the center of the world, as he claims it's doing. If the Earth was not at the center, then when the rock hits the ground, it would hit it at this kind of funny angle. It wouldn't be hitting it straight on. On the other hand, if the Earth, in fact, is at the center of the universe, then when you're standing on the Earth and you drop a rock, as it's approaching the center of the universe, it would be hitting the Earth kind of perpendicular to the surface. That's exactly what we see. And he uses that as an explanation of why the Earth is at the center, how we know that the Earth is at the center of the universe. Because if it were not, then when we dropped a rock, as the rock moves toward the center of the universe, it would hit the surface of the Earth at this kind of funny angle. Okay, now, after having talked about these things, what he's going to do now is talk about the shape of the Earth. What is the shape of the Earth? And I suppose on page 36, the first full paragraph, and he claims that its shape must be spherical. And here is where he provides these classic arguments of how you know that the Earth is round. These, by the way, are arguments that were contested by people who believe that the Earth was a different shape, whether polygonal or flat. And it's likewise, these are the same kind of arguments that people who believe that the Earth is flat today, they have to argue against these sorts of arguments that Aristotle is providing. I'd urge you to kind of think about this as if it wasn't already decided in your own mind that the Earth is a sphere. Looking around you, standing here on Earth, how would you know that the Earth is spherical? That's exactly what Aristotle is doing here. He gives a few reasons. First of all, he says that it is very natural to form a sphere when objects accrete on all sides, or kind of combine on all sides. So if the center, let's suppose that you're standing on the Earth and you drop a rock and it's seeking the center of the universe. So here's the center of the universe. If people are dropping rocks and they're all trying to get to the center of the universe, naturally, eventually, these rocks would accumulate and form a spherical object. So given his physics, given his notion of Earth or rocks seeking the center of the universe, the natural shape that would be formed would be a spherical shape. And if, for example, you dropped some object that was too big on one side, and it comes in like this, seeking the center, and it lands right here, it forms a new part of the Earth, and it pushes the Earth so that the new center of that larger composite objects is then at the center of the universe. So this is kind of the way that we can imagine the Earth forming as parts of it are accumulated at the center. Now, of course, Aristotle doesn't believe that the Earth had a specific time at which it formed. He believes that the Earth was ungenerated. It's been around forever. But he says if the Earth was generated, then this would have been how it happened. But on the other hand, if the Earth was not generated, as Aristotle in fact believes, but it's eternal, then it would still appear as if it had been generated in this way. This is interesting. This is the same kind of argument that people who believe that the Earth was created in 6 days, according to the scriptures, this is how they would explain, for instance, that Adam has a belly button, right? So the scripture teaches that that Adam was created by God as an adult, and yet he has a belly button, so he appears as if he was born in the ordinary way. So this is a similar sort of argument that Aristotle is using here. Another reason for the sphericity of the Earth is that eclipses, when you see an eclipse of the moon, the way that the eclipse forms is in a spherical kind of shape, which is exactly what one would anticipate if the Earth was casting its shadow on the moon and the Earth itself was a sphere. Another argument that he gives, and this is a very famous argument, is that from different locations on the Earth, different stars are visible. So as an example, here in Milwaukee, you can see the North Star. It's about 44 or 45 degrees above the northern horizon. But if you were to walk to the south toward the equator, down into Mexico and then into South America, eventually the North Star would dip and dip and dip and get closer and closer to the horizon until once you surpass or go south of the equator, then the North Star is no longer visible. So Aristotle mentions here that different stars are seen in Egypt than are seen in Cyprus due to the different latitudes, and this is precisely what one would expect if the Earth were spherical. This implies, he argues, a round Earth. Also, he mentions here that some people believe that there is one ocean, and this is kind of a corollary, I guess, a corollary of the kind of arguments that he's given here for the sphericity of the Earth, that there is one ocean that connects all of the Earth. So he says the Pillars of Hercules the water near there is connected with the water near India. And people who say those kinds of things just might be right, he says, based on the sphericity of the Earth. And also he mentions that elephants appear in both Africa and in India, different parts of the world. And this would make sense if the land masses were in some way connected, as they might be on a spherical Earth. Now, of course, none of these are slam dunk arguments. One could believe that the Earth is flat and come up with some other explanation for these sorts of phenomena, and that's precisely what people do. But he does mention that by looking at the stars and looking at the sun, one can not only conclude that the Earth is spherical, but one can actually measure the circumference and the diameter of the spherical Earth. And this is something that we will talk about this week in class during some of our lectures. In the meantime, I'm also going to post another lecture, not one that I prepared, but that's available on the internet from Invictus. And I'm going to recommend that you take a look at this video because it explains some of the aspects of how the ancient Greeks were able to compute the circumference of the Earth.